let's talk about voltage. Voltage is also known as a potential difference, and the way I'm going to talk about it, we're going to go back to the idea of potential energy. If you think about potential energy, it's always compared to ground. You know, how much potential energy do you have compared to ground? Well, the higher off ground you are, you have more potential energy. A little bit off the ground, not a lot of potential energy. High off the ground, a lot of potential energy. We can use that as an analogy for voltage, which is also a potential difference. So let's look at a basic series circuit. So I'm going to have a battery and 3 resistors, and then I'm going to add this ground symbol. So this corner of the circuit is connected to ground. Now, if you think about a basic hookup wire, can you have a potential difference of voltage change from this point in the wire to this point in the wire? Can there be, well, let's think about it in terms of pressure. Can you have high pressure in one place and low pressure in another place within one wire or hose? Could you have a length of hose that has high air pressure here and low air pressure here? No, no. In any hookup wire or a place where charges can flow really easily, very little resistance, almost no resistance, then what we end up with is we must have the same voltage across that entire wire. No potential difference. It's the same voltage across. So anywhere that is just a basic hookup wire, we're going to have one voltage at that point. So let's say that we've got this voltage here is ground level. And I'm going to just color that black. We're going to call that ground level. And the analogy I'm going to use is stairs. You can take stairs up to increase your potential. You can take stairs down to decrease your potential. So here, point A, I'm going to start at ground level, and I'm just going to draw ground all the way through. I'm going to walk around the circuit, and I'm going to figure out what's going on with the potential. Is it going up? Is it going down? And we're always comparing to ground level. So I'm going to walk around, and then I'm going to walk. First thing, if we start here and walk around like this, we end at the same place we started. So we end at ground level as well as beginning at ground level. So start and end at ground level. What's happening in between? All right, here we go. So we're going through the circuit, around the circuit like this, and what is a battery doing? Is it adding energy to the circuit? Is it taking energy away? You probably have a good idea, a good intuition that a battery is adding energy to a circuit. It's increasing the potential difference. So what a battery does is kind of like saying you're going upstairs. We're going to increase our potential. And so from A to B, we are going to increase. We're going upstairs. And I'm going to say 6 stairs. Okay, 1, 2, 3, 4, 5, 6. And now we're at point B. We have greater potential, and we're up here. Now, we have 3 resistors, and we know we have to end back at ground level. Does that mean a resistor is going to be adding energy or taking away? And there's multiple ways you can think about it. There's no reason, they all have the same current flowing through them. They all have to do the same thing, add energy or decrease. Your intuition is good here too. The resistors remove energy from the circuit, so they decrease the potential. They're decreasing the voltage across 2 points in the circuit. So if I have point B, I'm 6 steps up. Let's say that's a 6-volt battery. I'm going to say that we've got a 3-volt battery here, a 1-volt battery here, and a 2-volt battery here. Okay, here's point C, here's point D, and then we're going to get back to A. So we're right here, we're at very high potential at point B because the battery's pushing us up higher. As we go across the first one, the second one, the third one, we have to decrease our potential. The change in voltage from here to here, if we're 6 steps up and we got to get down, we got to drop 6 steps. There's 1, 2, 3, 4, 5, 6, and I just realized I messed that up. Let's fix that to be what a resistor is. A resistor isn't volts. What's a resistor? Ohms. Okay, there we go. Okay, that looks better. All right, so now I've got 6 total ohms. You can guess that each ohm resistance is going to be 1 step down. So from B to C, I'm going to reduce my potential. I'm going to reduce the voltage, and it's going to drop by 3. So 3 steps down. 1, 2, 3. Now I'm at point C. I'm going to drop 1 step going from C to D. And then from D back to A, I need to drop 2 steps. So 1, 2. Did I do that right? 1, 2. No, that's 3. We'll fix it by going like that. We'll make it look like this. There we go. So, as I go around the circuit, I'm going to start here at ground level. I'm going to go up 6 volts in potential energy, change in voltage. They're all kind of the same idea. So up 6. Now I'm here, and resistors reduce. They take away the energy. They lower the potential. So I'm going to go down 3. 1, 2, 3. As I go through this resistor. Point C. Okay, I'm here. I'm going to lose 1 step as I go to point D, and then I lose 2 steps, 1, 2, as I get back to A. So that's just a way to think about the potential in a basic series circuit. And there's another visual way that we can do this with actually going around in a circle. And I'll show that to you next.